I am a digital humanist. This is my close specialty, which means I explore the intersection between traditional humanitarian disciplines as history, linguistics, philology, and social and other types of humanitarian studies and social sciences, of course, and technological innovation. I have a background in classics, so I'm very familiar with the things that you were working with for the past few days. And regarding that, you learned how to encode your textual data into epidoc format, your metadata, and today authority, and today how to create authority files. You also had an introduction on how to upload your data to GitHub after you make a repository there, which is a which is a very useful skill. And today I'm going to expand on that topic, meaning how your data is going to be available to specialists and non-specialists on the internet. I'm actually using two computers right now. That's why I'm two times in the Zoom meeting. One, so I'm gonna share the screen of my other computer, and you're gonna see the presentation there. Okay. Just a second. So this is an introduction that will outline what are front-end services and web development in general. It's not a hands-on exercise. Neither of the things that I'm going to talk to you to talk about today are hands-on. It's not expected of you to know how to write code or use any of the tools that I'm gonna present. It just so you're aware of the mechanisms that are widely available and widely used, not only in digital epigraphy, but in web development in general. Okay. So, front-end development primarily focuses on the user experience and using the related coding and design techniques. Front-end developers build the elements of an application that are directly accessed by the end users with the goal of rendering the entire interface elegant, easy to use, fast, and secure, which means if your website abides by those principles, it's gonna have a lot of traffic and a lot of people are gonna have a nice time using it. If you make it more hard for use graphic elements that are hard to render, even if the data that you have on your website is nice, many people may not want to visit it again. So it's very important. As part of creating an engaging user interface, front-end app developers often focus on specific design elements such as text colors and styles, which were mentioned before in the workshop when you have certain glyphs in your epidoc files. We as front-end developers have the tool to visualize them the way the customer wants, the customer or client wants. We can also insert images, graphs, tables, button, and overall color schemes for data representation. These elements play a crucial role in enhancing the visual appeal and user-friendliness of an app. Front-end development encompasses various elements like sliders, pop-up forms, custom interactive maps, An essential part of front-end application is the navigational menus, which guide users through the application, enhancing their overall experience and interaction with the website or application. And the creation of an intuitive and user-friendly navigation menu is a key skill for front-end developers, and there's even a whole methodology called UX, meaning user experience, which focuses primarily on that. And people who think those concepts most of the times are not the developers themselves, but rather another part of their team. So I'm going to give you a simple example of every, or the at least the most common programming languages in general used for front-end development. HTML being the most close to XML. There's actually a format called XHTML, which is no longer in use. It had features of both XML and HTML. It's used to describe the structure of a web page and displays elements like headings, paragraphs, links, and so forth. Here is an example structure of an HTML. HTML is the same type of language as XML, meaning a markup language. As you can tell by the structure, doctype HTML is a declaration similar to the one that you start your epidoc documents with. Then you have the HTML element, which is the root element, similar to the TI element that you have in your epidoc files. And then the body, which is another element you have in your epidoc files. So you're gonna see a pattern because HTML, every element has a meaning and a function. The paragraph is going to show as a paragraph, and the P can't be used for anything else. The H1 is a big heading, like the one we see here with HTML basics. And the people who designed Epidoc had the XML structure, the HTML structure in mind. Because XML is extensive markup language, so every tag has a meaning that you assign to it, and it's used essentially for transferring data. So the next important element, and it's progressively becoming more and more complex, is CSS, or Cascading Style Sheets. It's a style sheet language that is used for describing the look and formatting of HTML documents. It allows the applications of styles like colors, fonts, and spacing of web pages. And here you have a example CSS code. The body, meaning the whole text part that you have on your web page, is gonna be light blue. Then your headings are gonna be white and aligned to the center. And then your paragraphs are gonna have this Verdana font, which is very popular for web development, and they're gonna have a font size of 20 pixels. Meaning, till now, we discussed HTML, which gives the solid structure, and this gives the stylistics of a web page. But we can have we can have only CSS and HTML, but our page is not gonna be interactive at all. It's just gonna display static text like you have a, for example, Word document running somewhere on a server, which is good for blogs and other types of simple text with pictures web pages. But if you want to interact, if you want your clients or users to interact with your databases or your website in general, you should add JavaScript into the mix. And it adds interactivity to the website, such as clickable buttons and animations. And here is a little example of a JavaScript code. JavaScript is a programming language. So the first part retrieves till the dot, retrieves an HTML element that has an ID demo. I hope you are following along. IDs are the same as IDs and XML. When you have ref, it's the same thing basically. So you find an element with this ID, and the second part actually says inner HTML, meaning replacing the contents of this element demo with the text hello world, meaning you can have an entirely empty structure which is filled with JavaScript information with JavaScript, which is essentially how most of modern websites work. And now for last but not least is PHP. PHP is a server-side scripting language for managing dynamic content and databases. Here we see the two tags PHP and a closing tag with a question mark and a bracket. And those indicate that the code is written in PHP inside of an HTML document. And echo is the output to the browser. And in this case, it would print salve. So PHP is used for extracting data from your databases stored on a server somewhere remotely and displaying it on your web page, essentially. So here is how it works. PHP is running somewhere on a web server, retrieving data to your MySQL database or just a database. It doesn't need to be MySQL. And using HTML, JavaScript, and I would add CSS here, it reaches our clients or users, because we may not monetize our website, as most educational or research websites are not monetized. So here's a quick overview. HTML says I provide the structure to the web page. JavaScript says I provide a functionality and content to the web page. Also, I talk to the server. And PHP says I'm the mediator between the database and JavaScript. This is one of the case scenarios. You can have PHP just running directly in the HTML, and then you don't have this step. You just go from index HTML to server PHP, or actually the opposite way around. So I know this talk has maybe become tedious, so I wanted to give a nice metaphor about the things I just said. So imagine the kitchen layout, HTML. Imagine the layout of the kitchen is like HTML, and it provides the structure and placement of elements, just like you have a stove, sink, refrigerator, and cabinets placed in specific locations in your kitchen. HTML defines where headings, paragraphs, images, links, and other elements should be placed on a web page. So this is the basic needs, the basic things you need to cook in a kitchen. Then you have the kitchen appliances or the CSS. The appliances and tools in your kitchen can be compared to CSS, just as you have a variety of appliances, just like a blender, toaster, or a microwave, to make your kitchen functional and aesthetically pleasing, actually. CSS is used to style the web page. It controls the color, font size, layout of the web page elements, making the site visually appealing. Like the way if you see on TV the kitchen of Gordon Ramsay, sometimes it may not be functional, but at least it looks pretty. That's the case for some websites as well. The cooking process or the JavaScript. When you cook, you follow a recipe, perform actions like chopping, stirring, baking, etc., and interact with your kitchen tools to create a dish. Similarly, JavaScript makes the web page interactive. It allows users to click buttons, open menus, play videos, and more. It's a programming language that brings life to the web page. And then we have the dish, the most important part, maybe. The dish you prepare is like the user interface or UI. It's the final product that the user interacts with, just as the taste, presentation, and temperature of your dish matter to the person eating it, the design, usability, and responsiveness matter to the user. And we should keep that in mind. And then we have the PHP, who is like a personal chef who prepares meals according to your preferences and dietary needs. Similarly, PHP is a server-side scripting language that prepares the data needed for the website. It can interact with databases, manage user sessions, and perform other tasks that aren't visible to the user but are essential for the website's function for the website to function correctly. And just as a personal chef takes your order or a request, prepares the meal or prepares the data and serves it to you, sends a response, PHP takes a request from the user, processes it on the server, and sends back the appropriate data to be displayed on a web page. I hope you like that metaphor. So, and the digital humanities front-end development is pivotal for presenting research data, visualization, and interactive elements because it ensures the accessibility and user-friendliness, enhancing the dissemination and exploration of scholarly content. As I told you before, if you see a website that is not user-friendly, hard to find things, even if the topic is interesting to you, 5 out of 7 cases are not gonna visit the website again. So I'm gonna talk briefly about TA Publisher here. I'm gonna talk about TA Publisher in a few minutes again, but in a more expanded version. TI as a standard for text representation is crucial in the digital humanities for encoding textual materials in general. NTI Publisher facilitates the publication of such texts, offering customization options through the TI processing model. More on that later. It simplifies the process of publishing text in various formats and enables the creation of standalone apps. Exists database is one of the, or maybe the only database that works with raw XML data. I'm not going to dive in detail here, but other databases use formats similar to Microsoft Excel, meaning table formats. There are some non-relational databases that use a format similar to XML in its functionality, but its syntax or the way you write the code is very different. Okay. So we have custom tailored engines like FS and our own Ajax. They're examples of engines that are tailored for specific needs within digital humanities, particularly in the application and visualization of scholarly content encoded in formats like Epidoc TAI. These tools offer features as edition visualization, search interfaces, and validation mechanisms, supporting the editorial and research processes. Very important tools. Some of examples of front-end applications in the digital humanities are digital archives that you can use to access historical documents and archives. One of the biggest such archives is the EBO, which stands for the Early English Books Online. It has around 40,000 books in it, every and each encoded. We have data visualization, which helps us, for example, display our places that we encoded in Epidoc on a map. This is an example that I can think just now. We have digital editions, meaning if somebody wants to make a digital edition of Shakespeare, he can publish it on a web page using TI Publisher. It's gonna have hyperlinks and it's gonna be more interactive than the book edition. And leveraging all those front-end development tools help engage users effectively to facilitate exploration and analysis of the research content at hand. Thank you. And I'm gonna move onto the next topic, which is TI Publisher. As you can see, the motto of TI Publisher is the instant publishing toolbox. TI Publisher is a very powerful tool that allows you to publish your digital editions without writing any piece of code, and it's based on the TI processing model, which means customizing the appearance of the text is all done in XML. This makes it highly flexible and customizable tool for digital publishing. Its core values align with open access data and the FAIR principles, because they have standards, the TI standards, which you are familiar with now. You have modularity, meaning you can reuse parts of the TI publisher's code in your code, not using the toolbox as a whole, but just use different modules and put it in a framework like Ajax or EFIS. And the reusability is more or less the same, because you can reuse smaller or bigger snippets of the code, and it's sustainable. The motivation behind TI Publisher was to provide a tool which enables scholars and editors to publish their materials without becoming programmers, but also does not force them into one size fits all frameworks. Meaning, you go to a programmer and you tell him, I want to have a digital edition of something, and he's like, and he suggests to use the layout of a, for example, e-commerce store. And one of the best things of the TI Publisher, except the things I said, is that experienced programmers can benefit from it as well by writing less code, avoiding redundancy, and improving maintenance and interoperability, just to name a few. TI Publisher is all about standards, modularity, reusability, and sustainability, as I said before. In terms of use cases, TI Publisher has been used for a variety of projects, such as an edition of Van Gogh's letters provided by the Van Gogh Museum, and the early English books online. Here is the Van Gogh letters, and here's the early English books online webpage made with TI Publisher. And when the slides are available in your program, you can go to the link and check out more demos, and even try to install TI Publisher and try to play around with your data that you have encoded. Let's talk about the features of TI Publisher. It all starts with your source documents, regardless if they're in TI or other forms of XML, like Dogbook. You can use textual data, which is in MS Doc as well, and JATS. No matter how the source material has been encoded, it can be easily transformed into a range of output formats for a publication, from modern web pages that you can open on every device, a phone or a laptop or tablet and so on, even an ebook, to a PDF file or a LaTeX source file. TI Publisher derives its name from TI and the TI processing model, PM. It defines how a TI document should be rendered in different output formats and lies at the heart of TI Publisher. However, online editions require more than just a text transformation. The text needs to be embedded into an application context, adding navigation, pagination, search, facsimile display, and so on. The larger part of TI Publisher deals with those aspects, providing all the necessary building blocks for an online edition. Staying true to the spirit of code reuse and interoperability. TI Publisher implements its functionalities as small Lego blocks to be freely arranged and recombined. This is a metaphor which is taken directly from their website. The technology making this possible is called web components. It is a part of the HTML5 specification and natively implemented by many browsers. Users don't need to dive into the details of the standard, though. All you need to modify the example pages is some basic HTML knowledge. As I demonstrated in the previous presentation, HTML is very similar to XML in syntax. You just have to know what each element does, essentially. Just like in Epidoc. Here, I'm gonna give you a couple of details about its TI Publisher's key features, like its high quality editions. You can create HTMLs, EPUBs, and PDFs from a single document and its associated processing model. TI Publisher also significantly reduces the amount of custom code required by typical digital edition projects. You can save thousands of lines of handwritten transformations and rely on maintained code libraries instead. The TI Publisher project has been going on for 9 years at this point. It started in 2015 and it's crowdsourced and crowdfunded and crowd supported. There are also online tutorials and courses available to help you learn how to use TI Publisher. For example, there's a 3-part online course called Stay Home, Learn TI Publisher from Scratch by Wolfgang Meyer. It's also been used to publish several to publish documents from several different archives in 11 countries, released by Diplomatic Documents of Switzerland to commemorate the 30th anniversary of the fall of the Berlin Wall. So that means TI Publisher has flexibility, ease of use, and a high quality of editions it produces if the Swedish government is willing to use it. However, as with this tool, it's important to consider your specific needs and requirements when deciding whether TI Publisher is the right choice for you. For example, many of the Epidoc projects don't use TI Publisher because it doesn't have native support for inscriptions, for epigraphic inscriptions. So as I told you, TI Publisher's ongoing development for 9 years. The current version of the software is 9.0, and it has major releases every year or every half year. And ideas for, and they have ideas for the future to incorporate wider formats and editing workflows as well. It also its components, as I said before, can be embedded into any environment, content management system, or block software, which is very important. Block softwares like Drupal, and I don't know if anybody uses Drupal anymore, but like it and WordPress. Or it can be integrated into other modern frameworks such as React JavaScript or Angular JavaScript, which I didn't tackle in the JavaScript section of the previous presentation because it's a whole because it's a monster because it's a monster all of itself alone. Okay, and let's go to our final presentation of this session. Also, if you have any questions or remarks, feel free to stop me and discuss them. Okay. So, an XSOT and expat gentle introduction. Those are languages or para-programming languages, meaning they're not fully programming languages. They just do stuff that programming languages would do, but they don't have the capabilities of, for example, Python or C++, and so on. And they are used mainly to manipulate XML files, which is important for us. XPath, which stands for XML Path Language, serves as a pivotal tool in navigating and manipulating XML documents, employing distinct syntax that is not tied to XML. It offers mechanisms for targeting specific elements and attributes within the document's hierarchy. Okay. XPath uses a path-like syntax to navigate nodes in an XML document. Path-like, like the way, for example, you have your folder called documents and local disk C on your PC if you're using Windows, and then you have another folder in it, and then you have the document, which is gonna be the last level. So imagine the chain of documents being separated by slashes. It's local disk slash documents slash my folder slash epidoc.xml.doc, for example. XPath was defined by the W3 consortium. W3 stands for World Wide Web Consortium in 99 in 1999. It contains over 200 built-in functions and provides robust capabilities of traversal and selection. XPath functionality and overviews. So XPath was defined by the W3 consortium in 1999, as I told you, and operates on the premise of tree structure, representation of XML documents. This structure enables XPath to provide a robust set of capabilities for the traversal and selection, as I told you before, and it has a node concept, meaning in XPath, every component of an XML document ranging from elements to attributes, text, comments, and processing instructions is considered a node. This comprehensive node model forms the foundations of XPath's querying and selection mechanisms, and we're gonna see it in a couple of seconds in practice. Location paths. At the core of XPath lies the concept of location paths, which describe routes to specific sets of nodes within the document. These paths can be absolute, providing an unambiguous starting point to the root of the document, or relative, which reference nodes in relation to a given context. For instance, this XML structure with A being to say the ancestor of C and B being the parent of C is expressed by this expression A, B, and C, with separated by slashes. And it's the simplest form of an XPath. But as I mentioned to you, there are absolute paths, which this one is an example of. But when it comes to relative paths, the problem becomes a little bit tricky, because relative paths starts from the current node, wherever you're in the document. It does not start with a forward slash. For example, if you're currently at the node B, which is the parent node of C, which is our context or self in programming terms, the relative path to C would be simply C, meaning in this expression, if it's relative path, you have only C. And this is because C is the direct child of B. So you don't need to specify the entire point path from the root. You can just refer to it directly. Node selection and access. XPath enables sophisticated node selection based on various criteria, including relationships to other nodes, properties such as name or value, and positional attributes within the document. Access serving as directional guides within the document hierarchy facilitate navigation to ancestors, descendants, siblings, and more. Predicate, first, maybe it's wise to explain the concept again. This is the ancestor. This is the ancestor. This is the self. The blue is the self or the context. A is the ancestor, B is the parent. But if we have, for example, D or C with an attribute being somewhere here or here, it's gonna be a sibling of C. If we have, for example, another element which is nested in C, it's gonna be a child of the same element. But if the child has an element, it's gonna be a descendant of C per se. So predicate filtering. Predicates offer means of refining known selection based on specific conditions, encoded within square brackets. Predicates allow for the application of logical expressions to filter nodes according to the desired criteria. And here is an example. We have the node bookstore and its child node book. But we want to refine our search so the book that's price is higher than 35 or greater than 35. And this is going to be, and in our web page, this command is only going to display those particular category of books. Okay. Adoption and application. Expat is widespread, is adopted across XML processing libraries and tools in languages like PHP with its component code DOM. In Python, it's XML E3 and C++ as well. And of course, we have Java. As I told you, expat by itself is not a language, but more like a paralanguage, and it has been adopted in those formats, as I said, because of its versatility and expressive power, having more than 200 built-in functions. And it actually had an influence on querying mechanisms like the CSS selectors, which I have shown you before, and here's an example. And this broader adoption underscores expat significance as a foundational technology for navigating and extracting information from XML-based content. There are some challenges and considerations regarding the use of expat because despite its utility, the level of expat support can vary significantly across different platforms and environments. While some applications offer robust expat functionality, others may provide limited support or lack compatibility altogether. This variability necessitates careful consideration when leveraging expat within diverse software ecosystems. For example, expat is reasonably supported in Firefox, and I would say Google Chrome, but I am not so sure about that statement. Yes, and here we have an example structure of a TI document, which you are supposed to that you have experienced these past days. And this is the expat to the title. We start from the root, we skip all the ancestors, the parents, and we go directly to the child element, which is title. And this is, we can, of course, we can write the whole code down, meaning ti slash body slash text slash div slash p slash bible slash title. But it's gonna be redundant, and very prone to mistakes, which can jeopardize our code. Another language for XML manipulation is XSLT, which stands for Extensive Stylesheet Language. I said extensive stylesheet language, which is the newer standard of XSLT, which is just XSL, but the T stands for transformations. It serves as a versatile language designed primarily for transforming XML documents into various formats, such as HTML for web pages, plain text, or even other XML formats. For example, you have a plain XML and you want to transform it into a TI compatible or an Epidoc XML. And you use this type of functions. Its capabilities extend to generating dynamic web content, transforming XML data for presentation, integrating XML-based and integrating XML-based system. And expat is actually a major element in the XSOT standard. So, XSOT is what just happened? Okay. XSOT is actually a very popular XML manipulation tool is and it has stable releases, not that often, but it has, for example, expat last last stable release was more than a decade ago. It was originally tailored for XML transformations, but its Turing-complete nature enables arbitrary computation, making it adaptable beyond primary purposes. Turing-complete systems are those intended for studying theoretical computer science. They are intended to be as simple as possible so that it would be easier to understand the limits of computing. So I would say, and many people who are working with Epidoc also master XSOT at one point or another. For an XSOT um, document transformation, the original document remains unaltered. Instead, a new document is created based on the content of the existing one, while XML files typically serve as input documents. Any data source compatible with building an XQuery or an expat data model, such as a relational database tablets or geographical information systems can be used. XSOT processors handle one or more XML source documents and one or more XSOT style sheets, processing them to produce multiple output documents. Unlike imperative or how to say functional programming languages like C, for example, XSOT adopts a declarative approach emphasizing pattern matching. Template rules or a template as we call them, and they have rules which define how to handle nodes matching specific XPath-like patterns, reflecting functional expressions that compose the result tree upon which the processor's output relies. XSOT leverages XPath extensively to identify subsets of the source document tree and perform calculations on them. XPath offers a wide range of functions, further augmented by XSOT itself. So this is how the theoretical materials that I told you about XPath are represented in a language similar to XML. XSOT shares its data model type system and function library with XQuery, initially conceived as a query language for large collections of XML documents. XQuery is similar to making a query in an SQL or SQL type database. And both languages actually incorporate XPath 2.0 as a sublanguage, which is very important. So, what are the distinctive features of those two languages? While sharing foundational elements cater to distinct communities and tradition, XSOT primarily conceived as a stylesheet language. Actually, in this manner, it's similar to CSS from the first presentation, and it aims rendering XML files for human consumption on screen, the web, or on paper. Right, as I told you, the plain text transformation. While XQuery serves as a database query language similar to SQL, as I mentioned. Okay, and now I'm gonna show you a live demo. First, we're gonna use this XSOT to transform an XML file. We're gonna visit this website. Okay, this is an example. I'm gonna put in my examples. I am not going to be using TI XMLs, just simple XMLs with the structure with the root library, element book, and in the element book there we have the children title, author, and price. And we want this XML to be rendered on a web page. So we use this type of structure. This H2 means a smaller heading. Those are paragraphs with the P and so forth. And now let's run it. Oh, excuse me, there may be an issue with the declaration. Yes. Okay. So now we have a web appropriate XML file, HTML file, and we're gonna return to our second link, which being this one, which is an HTML web viewer, and we paste it, and now we can see it on a web page. Keep in mind this is very basic HTML, and we can make it pretty using a style sheet, because imagine every time you see a web page, little to no developers these days write their CSS. We have libraries that we utilize like Bootstrap 5 or Booma or other frameworks. For example, here I am using Bootstrap 5 with its distinct structures. So we added this whole structure of div classes, and this is the output. If we really needed to modify the structure of the HTML, this is only for example, you can add this element style, and now your information about the author and price of the book is centered and in sky blue. You can, of course, make it right. It's gonna be on this side of the screen, or back to normal. You can do that for many of the elements. Okay, we're gonna do it for the, let's do it for the H2 element. I'm gonna copy this style sheet. And voila. But blue on blue doesn't look that good, so we can use a hex code. Distinct, this, which is something like very dark navy blue, but it's not black. I don't know if you can tell from your screens. And of course, you can add another element being HTML, and you can use background color to be, for example, gray. And then you have this part of your code, which turns gray. If we change it to body, we're gonna have all of our background. Okay, and I think this concludes my presentation on the topic of web development and different technologies. If you have any questions, I'm here uh, here all the time actually.